morning to all of you. As you all know how machine learning has made a significant impact on our society. So, taking that as a background, our third year AIML A section students are going to present two case studies on machine learning. So, here comes the batch 1 students who are going to present AI based structural health monitoring system. So, these are the students who are going to explain their case study. Introduce yourself.
Hi, I am Mary.
Hi, I am Trishan.
My name is Akshay.
I am Rishi. Today we are here to discuss a case study on AI-based structural health monitoring system. Good morning everyone. My topic is AI-based structural health monitoring systems. So we are here to demonstrate how artificial intelligence and machine learning playing its crucial part in monitoring health of monuments and buildings. Now I would like you to see a video. Imagine a young guy, Trishan, who earned his dream job. So he bought his dream car and going to his dream girl. Everything was happy until then. But suddenly there was a big ambush. He died due to bridge collapse. Is it his fault or the construction fault or it is an act of God? No one knows. Okay, consider if he is your brother or relative or a close cousin, how you would feel? Whose mistake is that? So this made me to think hard to find solution for this problem statement. So back then when I was in class 3rd, I remembered a quote, prevention is better than cure. What does it mean? It symbolizes that it is better to find a solution before the problem occurs. So, we and our team done a complete research on how to solve this type of problem. And before that, you can see various cases where in which in 2019 there are 6 lakhs lost, where in which 200 million words were lost. Similarly, in another country, another bridge collapse. Who is responsible for this? We don't know. And we came to a conclusion that by installing physical sensors in each bridge, we could find its vibration and can detect a bridge collapse. But coming to here, the actual price of this device is around 1.7 lakh. Considering the underdeveloped countries like Nepal, Bhutan, etc., it is very much difficult for them to buy each individual device and place it each bridge. It would be difficult, right? So I think this is not a feasible solution for its solution. So what we thought is that, what if we keep automated status assessment, where in which I guess every bridge will have a CC camera, and this camera will watch how bridge is being monitored, and we'll have a manual person who will monitor this thing. This will be everything done through manual. But the problem where it is lag is that there is miscommunication between the computer and the man. So we thought this is also not a feasible solution. So we engaged our brains to come up with a beautiful solution. This is where AI and ML works, advanced detection algorithms. So what is our core idea is that we will integrate artificial intelligence and machine learning algorithms in the CC cameras, where in which it will detect the frequency vibrations of the bridge and will let us know. I would slightly demonstrate how it is being worked. I think this is the threshold frequency. If the vibrations are below the threshold, it would detect as normal. So there will not be any interruption. Until if the vibrations were greater than the threshold, that means something going to happen. I personally believe that nature does not show a disaster suddenly. It will give us some cautions. So we are the ones to build the technologies to identify them. I would like to show a live demonstration how it is working. Consider this as a bridge. So imagine this is as a card. So while the car is going on the bridge, there will be slight vibrations. So these are the vibrations that were caused by car. So if there is any unwanted vibration or the vibration which is more than this, like sudden movement of the bridges and it will collapse, so there might be loss of life. So to overcome this problem, we found a solution. So I would like to invite my friends to explain the tech stack that is being used in these algorithms. Thank you.
Yeah, good morning to everyone. I will explain what is the working process, what are the technologies are used, what are the non-machine learning parts are used, what is vibration extraction, what are the vibration extraction methods are used. First we discuss working process. Yeah, step one is the camera captures the video. Here you are taking input from the camera. Camera captures through the OpenCV and optical flow. First, what is OpenCV? What is OpenCV? OpenCV means it is a library which captures and processes the video frames. Then what is optical flow? Optical flow means optical flow is used to calculate the dilation and vibration of the calculation. Coming to the second step, detect the structure. Here we use artificial intelligence to detect the structure. Here we use the YOVO V8 model. Here we use the YOVO V8 model. It removes the background. That's all. Coming to the third step, measure vibration. Here the system measures the vibration from the detector structure. Then from the detector structure, I analyze the video. Coming to the fourth step, here we use the methods like this optical flow and FFT. Here we use methods like FFT and optical flow. Coming to the fourth step, here ML decision. Fourth step is ML decision. Here ML takes the decision based on the input, how the bridge is, whether the bridge is normal condition or danger situation. Coming to the fifth step, display dashboard. Fifth step is display dashboard. After analyzing all the results by the machine learning, the results are placed in the dashboard, web dashboard. This is the working process. We are using technologies like artificial intelligence. Second one is signal processing. Third one is dashboard, web dashboard. Fourth one is we used machine learning. Artificial intelligence is used for detect the structure. Signal processing like FFT. FFT is nothing but fast Fourier transformer which converts time domain signals into the frequency domain. Then after we used web dashboard. Web dashboard means we place the results in the web dashboard. Next, then after we use the machine learning model. Machine learning model says that whether the bridge is normal stage or other danger situation which tells make the decision. Machine learning model. These are the technologies we used. Then after these are non-machine learning parts. For data capturing, we used OpenCV. It is a non-machine learning model. Next, for object detection, we use the YOLO V8 model. It is also a non-machine learning part. Next, vibration extraction. Vibration extraction is mainly in vibration extraction we use methods. Vibration extraction we use methods like OpenCV. Second one. No, not OpenCV. Vibration extraction we use methods like FFT. Just now I said FFT means a fast Fourier transformer which transforms time domain signals into the vibration signals. Next, This is FFT. Here we use another method like framing. Next, that method we used FFT framing optical flow. Just now I said what is optical flow. It is used to calculate direction and speed of the pixels. Okay, for object detection we use deep learning. Here, this is the part. This object detection here we use Euler VX model. This ignores the background details like cars, these tubelets, these all ignores. So it will only focus on buildings and whatever we want to bridges. Only focus on bridges and buildings. Then without using this object detection, we have to manually maps the bridges or buildings. That's why we are using object detection like Euler VX model. Next to framing difference. Framing difference is useful to detect the vibrations of the bridge. That's all. From here, our friend Mary will continue on the next slide.
So now, in the beginning, we have seen a sad story about the Drishan. So if we think about the bridge, if bridge could talk, it will ask the humans to help so that it will not collapse. So unfortunately, bridge cannot speak, but machine learning does. So now we are going to learn about how machine learning is used in this project. So first of all, what is machine learning? Machine learning is a subfield of artificial intelligence in which algorithms are trained on a data set to predict the patterns and analyze the patterns and predict the outputs. So being an AIML students, we have to know how the ML algorithms works. Machine learning is divided into two topics, supervised learning and unsupervised learning. Supervised learning is machines are trained with the labeled data, whereas unsupervised is machine without labeled data we train the machines. So this project is based upon the supervised learning. In supervised learning we will have classification and regression. In that we will focus on 5 main points. First one is collection of data. Second one is splitting the data. And third one is training the data. Fourth one is testing and validating the data. And fifth point is predicting on new data. So we will go in depth about these 5 topics. So we have given the title for the machine learning as brain of the system. So in general, as a human, we perceive everything with our eyes, ears, which are around us, and we analyze the data and do the actions, perform the actions. In the same way, for the machine learning, it will take the input data and it will process the data and gives the output. So since it is processing the data, it is named as brain of the system. And so this is the total overview of the ML, how it works. As Akshay said, we are collecting the raw video data through CCTV footages. So how it takes means in the form of pixels. It will divide into grayscale pixels and it will capture all the images. And next it will process the signals like vibrations and so on. And for the data, like input data, we are creating a feature vector. So we will go in depth in next slide. And we are using ML models and we are predicting the output. So now we are talking about feature vector. So what is feature vector? It is a collection of numerical data about the observation. For suppose, in this example, a bridge can have vibrations, amplitude and so on. There are many factors which are affecting the bridge. So those numerical values are collected in the form of vector. So this is called the feature vector. For this project, there are total 8 feature vectors. One is frequency, amplitude, RMS value, variance, peak-to-peak displacement, energy value, spectral entropy, and also zero crossing node example. So these are the input data for a bridge. These are all the parameters which we can calculate and process and give the best output. So now how it works? In order to predict the output, we have to classify the vibrations. So in general, there may be three kinds of vibrations. First one is normal vibration, second one is warning vibration, and third one is dangerous vibration. So whenever we are taking an observation, we have to classify whether that observation lies on normal vibration or dangerous vibration. Based upon that, we can give the alert signal to the dashboard. So in this, we are using three kinds of ML algorithms. First one is SVM. So first of all, data collection is done as we are collecting the raw video from the CC footages. Now the second one is training the data by classifying the vibrations. So first algorithm we are using is SVM, support vector machine. So let us understand in depth from the beginning about SVM. So let us take two kinds of observations. One is square, which indicates normal vibrations. Another one is circle, which indicates abnormal vibrations like dangerous or warning vibrations. So let us understand with the low dimension values, then we go with the high dimension of SVM. So let us take it as an x-axis. So there are some observations we are taking from the data. So these are the normal vibration data we have took, and also there are abnormal vibration data also we have taken. So our work is to divide this data into two parts, like classifying this data into two parts with the threshold value. So this is called the margin. So which it has a numerical threshold value. Whichever lies beside this, it will comes under normal vibrations. Whichever lies above that, it will comes under abnormal vibrations. So if you want to introduce a new data point, like if you want to introduce here, so it is near to this previous data set. So we can keep this threshold value here. So threshold value can be calculated in the way that it should satisfy all the data points and it can be very accurate while classifying. So this is called the margin value. So the distance between the previous data point and the threshold value is the margin value. So whichever has the maximum margin, like this is also margin, no? So whichever has the maximum margin, we classify into that. So this is called maximal marginal classifier. So we are keeping this threshold value based upon the previous two data points. What if those two data points are the outliers? So it may be the outliers. So when we are calculating threshold value, we get errors because of that outlier. So to overcome that, we are doing cross validation, checking each and every data point, cross validating in each and every point. We are fixing the threshold value based upon that. So because of maximum marginal classification, we are not overcoming the outliers. So for this, we are doing cross validation and doing support vector classifier. For example, if you take a graph, on x-axis we have frequency, on y-axis we have amplitude. So we are keep tracking of this observations, abnormal and normal. So we will draw a soft margin using support vector classifier, and also we have hyperplanes. Whichever data point lies between the hyperplanes, they are considered as a outlier. So in this way, support vector meshing. So combination of maximum marginal and support vector classifier gives the support vector meshing, which will accurately calculate or classify the data observations. And the second one is, second machine learning algorithm we used is random forest. So random forest, it will consist of multiple decision trees. So in general, decision tree is a iteratively like dividing based upon the decisions until it reaches the leaf node. So why we are using the name forest? So one decision tree is not enough to predict the output. So we are using multiple trees so that it will become a forest. So the actual meaning of that is forest. So what we'll do is, two main things we'll do: bootstrapping, and second one is aggregation. What bootstrapping is? So we have seen a feature vector which consists of all the data points of a bridge, like amplitude, frequency in the same way. So they are all the parameters of a vibration. So bootstrapping is used to divide the total data set into sub data sets so that we can draw a decision tree for each sub data set. So this is a large data set, consists of x1, x2, x3, id. So instead of drawing one decision tree to this data point, we are dividing that table into more tables like id and x1, id, x2. So in this way, we are dividing the data set by not repeating it. So that is called bootstrapping. And what is aggregation? So if this is a condition, x0 greater than 46, x1 greater than 20, it is yes. So we will basically classify into yes or no, two fields. So when we did bootstrapping, we have divided into many decision trees. So each decision tree will give a decision like output. So based upon the majority decisions given by the decision trees, we will aggregate, we combine all the decision trees and take the majority vote. So this is called aggregation. So in random forest, these two processes are randomly selected so that it will give the best decision. Third algorithm is XGBoost, which is also similar to the random forest, but the basic difference is, so in XGBoost, we will sequentially upgrade the decision trees. So in the level 1, if the decision tree has the only two splits, yes or no, so when we are going to build the next decision tree, we will rectify the mistakes which are done in the previous decision tree and we will add on to it and we will make the next decision tree. So basically for XGBoost we will have a loss function which is missing in the previous decision tree. Loss function of p comma q equals to sigma minus sigma p of x log q of x. So this function is used to find the loss of the decision trees such that we can add this loss to the previous decision tree and build the next decision tree. So first decision tree plus loss function equals to second decision tree. So this is about XGBoost. If we can see this picture, we have input features like frequency, amplitude, RMS value, variance and energy. So based upon that, each tree will give the best decision. So upon that, we will take the majority voting and we will finalize whether it is a normal vibration or warning vibration or dangerous vibration. So basically it is a majority voting of among all the decision trees. In the same way, XGBoost will build the trees based upon the previous previous decision trees and will make the final decision. So these are the three main ML algorithms which are used in this project. And my friend Rishik will explain the next.
So guys, till now we have discussed about classifier model. What classifier model does is, it takes input of the images which are turned into mathematical values. Those mathematical values are further converted into and run through a machine learning model, which is classifier model, which Mary discussed about. What that classifier model does is, classifier model only tells us that whether it is warning or it is normal or it's an anomaly. As it is trained upon supervised learning, it only knows the learned conditions. That is, it is trained upon like normal conditions and anomaly conditions. If anything goes other than these, like earthquakes, structural cracks, which are not trained to the model, this becomes a fault for our project. So to increase the accuracy, we have added another layer of another model, which is model 2, that is anomaly detection. What anomaly detection do is, it also detects the anomalies like which are not trained to the model. Like in classifier we have seen only detection of normal and anomalies. In these cases we can also identify disasters like earthquakes and structural cracks. What anomaly detection do is, it uses an algorithm called isolation forest. Isolation forest. It is very simple. Let's take an example of a class of 50 members. In a class of 50 members, and suppose take a class of 50 members and a person standing out of the class. Which person is easier to identify? The person who is standing outside. Similarly, if you take the normal data and an anomaly, it is easier to identify the anomaly. So we train the model with normal data. Let's take a graph. We map the normal data first on the graph. We also get the anomaly data as outliers. So what the isolation forest does is, it splits the data into different branches. Like it splits like this. These are isolated points. So how this works is, if the data is grouped, it is normal data. You can also say the normal data comes in groups and the anomaly data comes not usual, so it is unusual. So it comes as an outlier. So it is isolated and it is identified as an anomaly. As I said, we are using two models for the better accuracy. So how the workflow is done, I will show you. We take the camera input, then they are converted into mathematical data. Next it is sent to the ML model for decision. For this decision we are taking two models. One is classifier and anomaly. First the decision depends upon anomaly.py. Anomaly, if anomaly only returns two values, either true or false. If anomaly returns the value true, then the alert is sent directly to the authorities. If it gives a false value, then the decision depends upon classifier. It goes to a classifier. Then it tells us it is either it is normal or it is average or it is very harmful. So what we are making here is, if there is anything very dangerous, directly you are sending alert. Something is not dangerous and usual like normal warnings, then we will go for classifier. So what we are making here is decreasing the latency and decreasing the risk factor. So many people think that due to this machine learning system, we have a time latency and all. So by using such type of methods and two models, we are increasing our accuracy and also time. Next, the final output flow. ML output. As I said, ML gives the output either true or false. Next, then we have classifier and anomaly. These two are Python files. the data is sent through app.py, which is our backend. We have made it through Flask. We have used Flask here, and also some Python technologies and libraries. From this app.py, the backend, the data is then shared to dashboard. As we have seen, the data is sent to dashboard. Here we may get a doubt that we are using the machine learning model, but how come a normal person who is not skilled, who is not trained in machine learning, can identify the anomaly? So we have developed a dashboard which is easier to use, and the UI is very simple, so that a non-trained person, even a person with little skills, can easily identify the anomalies in that and report to the authorities. So here the 24-hour surveillance become very easy. Next, I'll briefly explain from first. Firstly, we have to detect from the camera what is the major problem is. We are saying we will use CC cameras, but the problem is the CC camera captures whole image, but in that whole image we need the structure. How to identify the structure? So in this identification, we use a model called YOLO. What is the importance of YOLO? I will be showing through a video. In this video, I have mapped the bridge which is made by Legos. It's a toy model. In that I have mapped the Lego. You can see that I will be mapping it manually. And then you can find some dots will appear on the bridge which are pixels, which are taken as reference. You can see that these dots are taken as referential points. So how much those referential points are moving, based on that we will get the frequency and amplitudes. So this is manual method. We can't do it every time, right? Manually mapping the bridge and selecting that, we can't do it every time. So for this we are using YOLO model. YOLO model is a deep learning model which automatically detects the structures and identifies them. The next step is the image data, which is converted into pixels and grayscale, then sent to the chart.js. Chart.js converts them into amplitude and frequency and send the numerical data to the ML classifier. ML classifier, what does ML classifier does is it sent to the anomaly detector.py. What anomaly detector.py do is it has the value either 1 or -1. 1 indicates true and -1 indicates false. If the case is 1, as I said, it gives direct alert. If the case is false, it gives the decision to classifier.py. Classifier.py classifies that either the anomaly is very dangerous or is just normal shaking or any heavy vehicles are moving. Next. The main point is the dashboard. The dashboard is very easy to, I will show Figma. So this is a dashboard which is very easy to use. This is, suppose we have selected a bridge section A. This is some bridge in location called San Francisco. You can see the live footage here. And the frequency, amplitude and condition is shown here. Go to the live feed. In the live feed, if we select any bridges which we need to monitor in live, we can select them and you can see here. In reports, in future we are also trying to train the models upon historical data. What historical data does is, based upon the historical data, if there are any checkings, like civil engineers, what they do is, they go for checking structures. They go for checking the structures. In normal cases, they need to go every time and check the structures. If we have such dashboards which make easier for them, here we also get AI confidence and status. Based on this AI confidence, the engineer's work is reduced to 0. Let's go to settings. So in the settings, we get email alerts and push notifications. In push notifications, we can integrate either WhatsApp notifications or Telegram notifications. So this makes the work very convenient. Directly, as we get the alert signal, it directly sends the connected email and push notifications through Telegram. If the both are not connected, it detects through AI and sends the signals to the nearest station, which is responsible for the bridge. So finally, we can conclude that the AI-based vibration analysis is replacing the expensive physical monitors, which are not only expensive but hard to maintain. This reduces the maintenance, the cost, and some countries, low economic countries like Nepal and Bhutan and other countries don't have so much money to afford such physical sensors. So we can implement such solution there. So the main plus point of our model is we are using 2 ML models. So the decision is very accurate. In case of emergencies, we get the alert very fast, and in case of non-emergency situation, we get the detailed solution. So as the missiles are also integrated, we have no problem. 24-hour surveillance is done automatically through ML and AI. That's it guys, we wind up the session here.